let's consider the sine graphs when b, or the coefficient of theta, is even. Well, same with the cosine. We're going to have double the number of petals. So r equals 5. I'm just going to hold that steady. Sine 2 theta. Well, if I play my theta r game and I choose pi over 4, now 5 sine of 2 times pi over 4. Well, 2 times pi over 4 is pi over 2. I have to multiply first, then take the sine. Sine of pi over 2 is 1 times 5 is 5. So notice what I get. I get this point for r theta. I get 5 comma pi over 4. And so I get something like this. Well, if there are double 4 petals, then each is going to be 360 divided by 4 is 90 degrees apart. So I'm going to have something that looks like this, because if I go 90 degrees, that's going to put me squarely in quadrant 2, and then quadrant 3, and then quadrant 4. I'm talking about if I do the spines here, right through the middle of these. So look, sine of an even number is living in the quadrants. By the way, we're going to have all 3 types of symmetry over the polar axis, over the theta equals pi over 2 axis. And you can see that first quadrant is looking like third and second is looking like fourth. So we're going to have across this pole that 0, 0 for r theta as well. Sine of an even number of petals is living in the quadrants. Notice none of them are bisected by either a vertical or horizontal. R equals 5 sine 4 theta. Well, I know that there are 8 petals. And each is petal length of 5. And it's an even number of sine petals. They love to be living in the quadrants. They don't want to be bisected. So I've got to put 1, 2, 3, 4, 5, 6, 7, 8. It's going to look like that. Notice, here's our polar axis, and here's our theta equals pi over 2 axis. We are going to have all 3 types of symmetry across the pole as well for these. Well, at least it's, we can tell automatically, at least it's going to be theta equals pi over 2 because it says sine. If I had 5 sine 6 theta, I know it's a rose with 12 petals. And because it's a sine, they hate to be, here's our polar axis, they hate to be bisected. They love to live in the quadrants. Well, if I've got 12 petals, then 3, a 1, a 2, a 3, have to live in each of the quadrants. A 1, a 2, a 3, a 1, a 2, a 3. So there's a rough graph, and it all hit through that point. I have all 3 types of symmetry here. Polar axis, theta equals pi over 2, and you can see first and fourth quadrant, first and third quadrant, second and fourth quadrants also have symmetry, so we're going to have symmetry across the pole as well. By the way, for any of these sine graphs, if I took a negative outside, that means I'd have to reflect over the polar axis, up and down flip, and we'd have the same picture. So it really doesn't matter if it's negative or positive for the even numbers.